here to battle it out for the JEE examination, and many of you might be even 2021 aspirants. So even if you are a 2021 aspirant, you are welcome out here. And obviously if you are a 12th standard student and who is going to give the examination next year, well, this Pathfinder series is exactly for you, and we intend to complete the entire portion of the 12th standard on this channel for free of cost for all of you. And we have already done electrostatics and Gauss law, and current is also done. Next week I'm starting with capacitors. So get ready guys. Thank you for all the fire and all the hearts out there. Well, Midnight Monster, hello. Well, you are in 11th. I believe you can still attend, no problem. But for you guys, we have the Nurture series. So Nurture for 11th, Pathfinder for 12th, and a Rank Booster series, especially for the 2021 students out there. Hi Vladimir, nice to see you back out there. Yes, let's rock it. And guys, please just smash that like button. And do not forget to hit the subscribe button in case you are new to this channel. And yes, join our Telegram channel in case you want all our PDFs out there. Now, first of all, this is the schedule for this week. I just completed the expected dates for JEE Mains and JEE Advanced for this year. Please go watch it in case you have not seen it yet. A lot of important strategies and a lot of important news which has been disclosed out there. Now, tomorrow there will be an advanced session on vectors. So that's for 11th standard students, but yes, the 12th standard students are allowed to gate crash over there. Yeah, just please be mild on those students. They are, which are 11th standard students, and you guys are 12th standard students, so you obviously will have an extra edge and a special session for all of you on Saturday. Now there is a very important announcement. Vedantu has planned a very important thing, which is an initiative for all the kids out there who are affected because of this pandemic. Now, a lot of people are doing a lot of good work, and we should not be held back, in contributing our efforts for all those kids who are affected by the pandemic. Now, if you want to know more about it, please go ahead to this link, which is helpindialearn.in. Please understand, a lot of kids are, suffering for different reasons, financial, emotional, and other things. So we want to help, and please contribute in any way that you can in this initiative. If you know somebody and who needs help, please let them know about this initiative as well. And by the way, for you guys, who are preparing for the next year, let me tell you some interesting things. If you're already a student of Vedantu, your chances for clearing the JEE Advanced is at least 6 to 7 times higher than a student who is not in Vedantu. Look at the percentages of students who have cleared JEE Advanced and got into IITs. 8.25% of the students from Vedantu get into IITs, whereas the national average who prepare everywhere else, it's 1.25%. Students who do well in their board examinations is also 5 to 6 times higher. So guys, if you are a student of Vedantu, the chances are really, really good. They look really good for me. Your future is bright. And if you want to make your future bright, we have a pro subscription right exactly for all of you, a long-term batch which is going to start on 14th of June. And there is an English batch and a Hindi batch which are separate, not like other institutes. And if you see the per month cost, it's very reasonable. So I'll tell you more about these plans, the light, classic, and the plus version later on. But remember, the long-term batches are about to be started with all the live classes, with the recordings, with the material, with the assignments, test series, and everything that you would expect. In fact, more than that. The link for that is there in the description box below. So let's have a look at our first question out there on our screen. So let's see if you can figure this out. I'll give you a minute. Just meanwhile, I'll keep interacting with those of you who are asking anything on the chat box. This is your question. There is a lamp over here. A, B, C, D points are marked. There is a battery, there is another resistor. All these resistors are identical. Now, if you want this lamp, that cross one, to become dark, where should this extra resistor be connected? Is it possible? If possible, which of these? If it is not possible, then the option D. Okay. So why current electricity not decreased which passing through a resistor? I'm not sure what exactly is the intention, Ankit, of that question, but yes, Venkata, we should solve previous year question as well. Catch 7, instead of Menti quiz, I have planned the advanced series, because In Menti quiz, what will happen? Again, I'll have to collect a lot of simple questions. Instead, I thought I'll do really good questions in this advanced. Don't worry, we'll also have a Menti quiz sometime later after capacitors. Hi Shreya, hello. Hi Bharat, hello, welcome aboard. Good evening, Polosi, EJ. Yo, Bhargav, I'm very good. Thank you so much. Very good, Vikram. Yes, Bharat, I do remember you. Polosi, I think this is little bit more for NEET. This is advanced level, but yes, you are free to attend. Vanakam, Ankit says B. Well. If you're talking about Ankit, going back to Ankit's doubt, why current electricity not decrease which passes through a resistor? Ankit, see, there are two things. One is an ideal resistor which does not get affected by heat and all that. So if it's an ideal resistor which does not get heated up, which is not possible, then nothing will change. But if by passing current the resistor gets heated up, and once it gets heated up the resistance increases, and because the resistance increases, that's why the current will decrease. That effect is minimal. The changes due to temperature are less, but often ignored. Okay, Rahul, no problem. Oh, no problem, Bharat. Even if you are a NEET student, I think this will be a little bit over the board, but you can attend if you want to. Okay, chalo, let's do this question. I'll tell you what I'm going to do. Oops, yes, the answer is C, by the way. I have just showed the answer, but it's okay. I just want to solve this now. I have given you enough time. Okay, now let's see how to do this. First of all, I'll redraw the circuit. Believe me, this is supposed to be redrawn because I think this is in disguised form. This is what I'm going to do. So this same circuit, what I'm going to do, I'll put the battery on the top. This one, I'll call this resistor 1, resistor 2, resistor 3. This branch, I'll bring it here. This branch, I'll bring it there. Because both these branches have the same potential difference A and C. So this is how it's going to look like. This is point A, but I'll bring this resistor 2 here. It's one and the same thing. It doesn't change much. Point C is over here. And then you have this another resistor which is numbered 3, and it goes over here to point D. This branch, I'll bring it down over here, and there is a resistor labeled 1. This resistor 2 has been brought on the top, and there is a bulb over here, okay, and that bulb has this point as B, and that point has been connected to C. Does everybody realize what we have done? We have exchanged these branches. The branch on the top has been brought below, and vice versa. It doesn't matter because the potential difference is still AC. Everybody clear till this point? Hey Shivi, welcome aboard. Join in. Great. Now comes the next part. Okay. Now what I'm going to do? I'm going to do a small thing. I'll just take this bulb and make it straight, vertical. I'll just make it vertical. So how will this look like? Well, there is that battery, and then you have that point A. Then you have this resistor number 2, and then you have that point C over here, and then you have resistor number 3, and it's connected to point D. This resistor below, I'll just show it as it is, resistor number 1. I will make this bulb straight. That means I'll put this bulb over here and I'll connect it like this. This is point B. Now, this reminds me of something. This just reminds me of something. Guys, it's clearly told the lamp has been made dark. That means it turns off. If it turns off, that's why it becomes dark. That means the current through that lamp is 0. How can I make it 0? How can I make it 0? I don't think so, Jammer. You don't require so much knowledge of electrostatics. Little bit is required initially, maybe here and there, but as such, 90%, 95% you don't require. Okay. Bharat, I am from Pune, but right now in Bangalore. No problem, Shivani. I know you had a class right now. Yes, it's a Wheatstone's bridge, Abhi. Correcto. This is a Wheatstone's bridge. I just need to add one more resistor over here. Okay, I just need to add one more resistor here, resistor number 4. This is that new resistor. Now it's a balanced bridge because this is R, this is R, this is R, this is R. So this will not have any current, and hence no current will flow. So where is that extra resistance? It is between B and D. Do you see the creativity, the visualization, the level of thinking, the out-of-box thinking that is needed for this question? You need to think, how can I rearrange the circuit? Oh, it's a Wheatstone's bridge. This has to click at the right point. That's when you will be able to solve it in the JEE Advanced examination. So beautiful question. So the correct answer for this is BD. And I feel that this was such a nice disguise. I mean, this is probably better than Mr. Bean in the movie Holiday. Yeah, everybody, yeah, loved it. And if you loved the question, please go hit the like button out there. And if you are new to this channel, so guys, this is an English channel for all the JEE enthusiasts. So please go hit the subscribe button in case you have forgotten to do so. Yep, that's Mr. Bean. Yep, that's Mr. Bean. You can recognize him, but recognizing Wheatstone is much more difficult. Do you guys agree or not? Okay, let's get going. Ankit, that's Mr. Bean. I hope you have watched his series, his cartoons. They are really funny. You should do that. Okay. Well, here's the next question. Look at that. Probably you should say, what the hell is this? Okay. And the question is, what's the equivalent resistance between these 2 points? What is the equivalent resistance between these 2 points? We Enthuse FC, instead of Menti, we are conducting the Advanced series. So I'm pretty sure you know this, that, you know, I want you guys to also scale up your level. I want you to do the difficult problems. Don't worry, Menti will also be conducted as a combined session for maybe current and capacitors. We can do it together because they are related to each other. Okay, for now, concentrate because this is also very important. Okay, baby Kiara, oh my God, what name you have? From where do you get these names? Okay, so, well, the need date, most likely it should not change, but if they give it as a slot, then it might, slot for board examinations, it might change. So then it might be shifted to September or something. Okay. Well, a lot of you are saying A or D. Okay, I don't know. Some of you are even saying C. Well, I don't know. I'll tell you what should be done. This is the diagram. Okay, this is the diagram. Now look at this beautiful way of doing this. Guys, the current, okay, comes from the top and it goes out like this. Here it comes in and it goes out. What will happen to this current? This will get distributed equally everywhere. So the current which comes in, it will go here, 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 and it will go here. It will go everywhere, all sorts of things. And eventually, it will come back like this. You can see from all these branches out here, like that, correct? And it will collect and it will go out. So the current comes in, gets distributed, comes back, collects over here at that junction and goes out. Now don't you see, because all the wires are of the same resistance, all the sides of this complex polygon, all right, is of the same resistance. That means the currents will get divided equally. If the currents get divided equally, by the time the currents reach here and they encounter some potential drop, don't you see this point, 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 and this point, all are at the same potential? Do you see they are all at the same potential over here? Everybody seeing that? Yep. Whenever I made a mistake, looks like many of you realize what mistake you have made. Yes. And similarly, this point, 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 all are again at the same potential. And what is that thing which I have told you about potentials? If 2 points are at the same potential, then the current flowing is 0. So this part is useless. It's useless. There is no point of having that wire or that device because there is no current flowing through it. It's as good as you throw it. Nothing will happen. Things won't change. So you can remove the wires which connect this point, this point, this point. All those circles, whatever lines are there, visualize, disconnect them. All these crosses, whatever sides are there, disconnect them. So how will it look like? It will look like this. It will look like this. Do you see that? Do you see that? It will look like this. I've just removed those wires which actually connect these 2 points. Remember, this point and this point are at the same potential, that side. So you can as well remove it. That's what we have done. Now guys, it looks like a very crazy diagram, but it is not so difficult. Just count the number of branches that you have. 1, 2, 3, 4, 5, 6, 7 and 8. Are all these 8 branches? Are all these 8 branches in parallel? Do you see that? Are all these 8 branches in parallel? Yep, everybody is seeing this. And each branch, what is the resistance of each branch? Think about it and tell me. 1, 2, 3. 3 resistors in series. So it will be 3R. 1, 2, 3. 3R. Do you see that? Yep, it's not R by 8. Be careful. It's 3R resistors because they are in series. They are in series. 3 R's are in series. Any branch you take. 1, 2, 3. So 3 R's are in series. Now, if you have 8 such 3 R's in parallel, because there are 8 branches, each branch is 3R. So what is the effective resistance, guys? What is the effective resistance? Come on, think about it. 3R, 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 3R in parallel 8 times. So what will it become? 3R by 8. Is that clear? 3R by 8. In case you did not figure it out, why I got 3R by 8? It's nothing but 1 by R effective is 1 by 3R plus 1 by 3R 8 times. 8 times. So it will be 8 by 3R. That's the reciprocal. So flip it. Yes, that's the reciprocal. So it will become 3R by 8. Understood? Yeah, Ankit, I hope this is clear why it is 3 by 8. 1 by 3 plus 1 by 3 plus 1 by 3. How many times? 8 times. So it will become 8 by 3R. Well, that is 1 by R. Remember, in parallel, it's 1 by R effective. So flip it. So that's why 3R by 8. Got it? Very good, Surya. You should be proud. Understood, says Yalni. Very good. In search of life. Very good. Very good. Very good, Priyanka. Monkey D. Luffy. Yes, but the wires are said to be R. Each wire segment, Kirito, each segment is R. That means this one, this one, this one. All the wires, each wire connecting these 2 points, the nodes which are connecting those wires, the resistance between them is R. Okay, cool, great. So that's the answer, 3R by 8. Beautiful question out here. Visualization, creativity, that's what advanced examiners look for. Next question, based on mathematical skills and formulas combined together. Let's see whether you can get this question. So you have drift velocity proportional to the electric field inside the conducting wire. There is current flowing, drift speed is proportional to field. Then the voltage versus current graph for such a wire will be which one? How will it look like? Please understand there are 2 kinds of resistors, ohmic and non-ohmic. So most likely it could be non-ohmic depending on what the final expression comes out to be. Yep, very good, Aman, you understood it. Gem, Monkey D. Luffy is Kirito, okay? Funny names everybody has. Yo. God, it says Munnavai. Yep. Everybody is fine. Nice to know that. Everybody inquiring about each other's health. Good, guys. Keep it up. So, how to get the idea? That's why, Bhargav, you are seeing how I am seeing the problems. See, I'm trying to solve from the scratch. I'm thinking from the scratch. So, look at how I solve. You will get an idea. And number 2, solve more problems like this and solve it on your own. And once you get the hang of it, looking at first line of the solution, taking hint by 2 lines of the solution, then you will start thinking in that way. See, nobody can train you to think in a particular way. You have to develop these approaches. And few of the things which are there, like shortcuts or important things, I'll be telling it to you, as and when we do problems. In the previous problem, symmetry was there. So I used that fact that there was symmetry in the previous one. Okay, some of you are saying A, some of you are saying C, some of you are saying B. Yep, let's see how to solve this question. Well. Come on, guys. Okay, yes, I'll be giving you the idea. Don't worry. Yep. Okay, sir, V is proportional to root of I, says Nidish. I don't know. Let's figure this out. Drift velocity, is there a formula? I think so, yes. It is I is equal to N VDEA. Okay, current is, then you can see NVIDIA, I had told you this formula. current is then going to be proportional to the drift velocity. N is a constant, E is a constant, area is a constant. Naturally, current is proportional to drift. But drift is proportional to root E. Therefore, current is directly proportional to root of E. I'm just saying proportionality. If A is proportional to B, B is proportional to C, naturally A is proportional to C. A to B, B to C, A is also proportional to C. Okay, now what do we do next? Well, I want to get voltage and current. I have current, I don't have voltage. Do I know something which relates voltage and field? I think so, I do. Yes, I think so, I do. And what is that? Remember, field is rate of change of voltage with respect to distance. Field is nothing but potential gradient. That was the formula, potential gradient, magnitude wise. And what will you get from this? Field is E, potential gradient is voltage difference. Now voltage difference itself is V by delta X. From this relationship, can you not see that field is actually proportional to voltage? Field is actually proportional to voltage. That means again over here, I is proportional to root V. Therefore, root E. Therefore, I is also proportional to root of voltage. Yep, it is proportional to root of voltage. Now that's what I wanted. Flip it and square it. Yep, just take it on this side. So root V square is V and I square will come on the right side. Voltage is proportional to I square. What is this graph going to be? It's going to be a parabola. Which bola? Parabola. So which graph is a parabola? Such that it is like this. It should be upward parabola. So I think this is the only graph which is an upward parabola. Yes, and that's answer C. Beautiful. No, Rakesh, this is not a Menti quiz. So instead of Menti quiz, for all the people who forgot or who missed that announcement, I am conducting advanced series. Because in Menti quizzes, what will happen? I will just give you a little time and you won't get that opportunity to solve good level questions. So do you want good level questions? I'm pretty sure you want, right? Please let me know. And yes, Menti quiz will also be conducted after some more time. Okay? After capacitors, I'll have a combined session of capacitors and current electricity maybe. Okay, don't worry guys. Yeah, that's the question and that's the answer. Beautiful. And by the way guys, all those people who feel that YouTube and Vedantu platform looks the same, well, definitely not. Like you attend my classes live over here, our platform which is there, it's called as a wave platform. The teacher is seen here, there is a chat box, there is another teacher. Like we have an admin over here, there is a class teacher, but he is also a subject expert and he will be solving all your doubts on the flow. So your class is divided into small groups and each group has a teacher. So anytime you have a doubt, you ping your class teacher and they will solve your doubts, academic, non-academic. And your teacher is teaching so that the flow is not broken and each group is separate. So you have that that bonding in those small groups, your class teachers and you have very good learning outcomes because of all of this. And by the way, the entire class is recorded and you get the PDF with whatever you write on the whatever the teachers write on the notebook out there, and you can get all those notes till the end of the examination. You don't have to think about, oh, is there a time limit for it? No, there is no time limit. Okay, let's go to the next question coming up on your screen, and here it is. In this circuit, R1, R4 is R2, R3, then which of the following statement or ments will be correct? More than one may be correct. No, Vikram, I'm not tired. I'm in fact, maybe I might look tired, but internally my mind and my heart is like, my God, this is an advanced session, and that too my minions, my warriors are over here. I really want to do this for them. I really want to do this. Guys, whatever happens, I'm there for you. Let me tell you. Thank you, Pradyumna. Okay, says minions understood. Yes. Peons speak. Oh my God, Rakesh. Okay. By the way, more than one option may be correct. Be careful about this. Guys, I was very surprised and I felt very sad one day. I'll tell you why I felt sad also. One guy told, sir, you taught Wheatstone's bridge and you told that this is 1, this is 2, this is 3, this is 4, and when you taught, you told 1 by 2 should be equal to third resistance by fourth resistance. These are just resistances, not exactly numbers. R1 by R2 is R3 by R4. But in the book it was given, sir, 1 by 3 is equal to 2 by 4. R1 by R3 is R2 by R4. Sir, is this wrong? Bhai, please, okay, just rearrange. Come on, if you take that 2 here and if you take that 3 on the top, isn't it the same thing? So don't get confused, okay? Chalo, let's see how many of you got this correct. Some of you are saying A, some of you are saying AC, some of you are just saying C, some of you are saying CD. Very good, Shivani. Josh is high. Kick-ass. Very good, very good. Okay, ACB. Okay, let's see. Let's do this one by one. If you interchange the positions, let's see what happens. How does this circuit look like? If you interchange the positions, okay? Let's do this one by one. Okay, so you have the battery over here and you have those resistors like this and resistors here and resistors here and the galvanometer over here. Now let me tell you, when you do this circuit or when you write this circuit, okay, this is 1, this is 2, this is 3, this is 4. This circuit, okay, I can write it as, what you should do is visualize, guys. Oh, sorry, this was galvanometer, my bad. And this was galvanometer, okay. What you should visualize, take this galvanometer inside. Just take it inside and connect it between these 2 points. So what you will have is this. Just take this galvanometer connected between these 2 points like this. Yep. And now what you do, take this battery outside. Just take this battery outside. Something like this. Now think about it. This is 1, this is 2, this is 3, this is 4. Is it not still a Wheatstone? Just rearranged in a different way? Is it not a Wheatstone just arranged in a different way? Look at this. The current from the battery goes here, gets distributed in 2 branches. Now think about it. Is 2 by 4, second resistance by fourth resistance, equal to the first resistance by the third resistance? 2 by 4, is it equal to 1 by 3? Just look at it. Well, if you don't believe this, look at this expression. 1 into 4, yes, 1 into 4 is 2 into 3. Yes, it is. 1 into 4, R1 into R4 is R2 into R3. Yes, so it is balanced. If it is balanced, there will be no current here. There will be no current over here. That means the galvanometer will show 0 deflection, which is correct. Yes, so you can exchange these positions, nothing will change. Yep, that's how it is. Beautiful. So first option is done. Okay, now the second option. If the battery is reversed, galvanometer deflects to the other side. Guys, because this condition is given, it already means this is balanced. It says balanced, guys. Come on. You can just rearrange this. You can see that, you know, R1 by R2, all right, is equal to R3 by R4. You can see that. 1 into 4, 1 into 4, 3 into 2. It's balanced. Because it is balanced, there is no current. Current in the galvanometer is 0. Now it doesn't matter whether the battery is more powerful or less powerful, or even if it is reversed. So if the battery is reversed, or even if you double the EMF, then even then understand the galvanometer will show no deflection. There will be no deflection only. Here it says it deflects to the other side. So obviously B option is wrong. It says it deflects to the other side. How can it deflect? It will be in fact having no deflection. And in option D it says if galvanometer is not ideal, it will show deflection. It doesn't matter even if the galvanometer has some resistance. The current will not flow between these 2 points, irrespective of what that galvanometer is made of. Even if you put a donkey there, nothing will flow through that donkey. So whether it is ideal, not ideal, it will show deflection. This is wrong. It will not show any kind of deflection. So in fact, option D is also wrong. Yes, option D is also wrong. Understand that. And yes, oh my God, so you are seeing a lot of deflection words out here. Okay. If EMF is doubled, then deflection shown by the galvanometer is not there. This is correct. Now, by the way, it doesn't matter. Even if you triple it, quadruple it, half it, doesn't matter because it is already balanced. So no deflection. Yes, that's what it is. It is already balanced. So basically E doesn't matter. So the direction of it, the magnitude of it does not matter. If there is a battery, that's it, it will be balanced. You don't have to worry. Yeah. So only option A and C is correct. Everybody clear about this? Yep. Is that clear? Yes, Pradyumna. Yep. Is there a way of any way of getting full marks? Well, Mala Mohan, I don't know of any person who has got full marks in JEE Advanced. JEE Advanced is a special exam where even people who get 60 to 70% get into IITs. It's a tough examination. No, see in real life, see what are marks at the end of the day? You know, it's just telling you how well you understand problem solving. Nobody is perfect in this world. You cannot expect a real world scenario to be solved the perfect way. There is nothing like perfect. So the same thing is also in JEE Advanced. Nobody can actually solve all the questions out there. There are people who solve 80%, 90%, they get very good ranks, top 10 ranks and all that. But understand, most of the people 60, 70% and they are in IITs. And that is okay. Don't think of it like board examinations where I have to get 100% marks. That's not true. Okay, let's get going. Yeah, A and C were the correct options. Let's go to the next one. Yeah. Ram, Prakash, welcome aboard. Yep. Yo, I don't know what it means, VK Vera, but I am guessing it's something good. Okay. So do you listen Fat Rat Rise Up? No, I have not listened to that, but I have heard a very crazy song. You should also hear it, and that's called Eye to Eye, and it's got crazy tune. You will fall in love with it. Eye to Eye, and I don't know, it's crazy. I mean, yeah, please watch it. Yeah, the lecture on magnetism, Amaya, will be there after some time. After capacitors. Yeah. Let's see how many of you can do this. Find current density as a function of x. Okay, so thank you. Integration, I don't know. Well, Ankit says he only listens to Shreyas Sir's lecture. Yes, Ankit, definitely. Oh yeah, Dinchak Puja. Yeah, I'll definitely. I do listen to Dinchak Puja. Favorite singer and favorite artist for Shreyas. Dinchak Puja, Tahir, all these are my favorites, like crazy. Yeah, let's see how to solve this. Okay, now, okay, you don't know VK Vera. Now let's see how to do this. Do you agree that even if the cross section varies, whatever flows through first cross section, middle and third and last and anywhere else, the current flowing will be the same through all the sections, no matter where I take that section? It's just like saying there is a highway which increases in width. There are some cars entering in. How many cars come in and how many cars go out? If I ask you that question, how many cars come in and how many cars go out, the road becomes big. Obviously, you will say same. I mean, come on, there is no Godzilla or King Kong out there which is breaking all the cars in between. And the cars which are coming in are more, cars which are going out are less. No, that's not the case. Or it's not like somebody is magically producing some cars and more cars are coming out. Obviously, cars going in are cars going out. Yeah, correcto. Exactly. Yep. So, the current in is current out and the current everywhere is same. It's like equation of continuity. Now, the thing is, once I know this fact, I want to find what is the current density. What is the formula for current density? It's current by area. It's current by area. Yes, Vidya, many happy returns of the day and God bless you, my child. Take care. Thank you for being on this channel and very special day for you too. Okay, now this area of cross section, for finding that area of cross section, I need the radius. Isn't that so? So current density is current by area. For area, I need the radius. For that radius, what do? I need geometry. For that radius, I need geometry. Let's do this now. How do I use that geometry? Let's observe this carefully. What I'm going to do is this radius. I have to find that out. I'll just draw a line like this. Okay. Now think about it this way. I'll call this as y. Okay, what is this? This is y. This much as x. This much is x. Okay, this much is x. This much is y. Don't you see there is a triangle here and there is a big triangle here? Do you see two triangles? There is a small triangle here and the big triangle here. Triangles are similar. When triangles are similar, then don't you know that the sides are in ratio? The sides are in ratio. Everybody knows this fact. That means y by x will be this by this. Now how much is that? How much is this? How much do you think is this much? How much do you think this much is? Well, this whole thing is b. This thing is a. This thing is a. This thing is b. So how much is this? The leftover part. Yep, think about it. It's b minus a, right? Yeah, it's b minus a. Yep, b minus a. So guys, what will I put over there? I'll just put b minus a, which is this upon this length. What is that? That's L. Correcto. Yes. Now, what is this radius? What is this radius? This radius is this plus this. This radius is this part plus this part. What is this part? Well, that's A. Plus, what is this part? That's Y. I need the radius. Do not forget that. Yes, I need that. So, A plus Y gives me the total radius. Everybody clear till this point? So, what is Y? I know from here. What is the value of Y? Y is, take that X over there. So, I'm going to get A plus B minus A by L, the whole thing into X. That's the value of R. Everybody got this? Yes, A plus Y. Excellent. A plus B minus A by L into X. That's R. Why did we do all this? Because we wanted current density. So now, current density, which is current by area. What is the area of that cross section? It's pi r square. Pi r square is the current, is the area of that cross section through which the current is flowing. So what is the value of R? Well, R is this whole thing. So A plus B minus A by L into X, the whole thing square. The whole thing square. Everybody clear about this? Let me know in the chat box if everybody is clear about this. And that's the value of J, and that's the required answer. Yes, that's the required answer. Yep, that's it. That's the first answer that we just got. Current density. Cool. Now understand the next question is field. We need to figure out the field. Is there a formula for field? I think so there is. One is delta V by delta R, but there is no use of that. But I think there is another formula. E is rho J. E is rho J. Yes. Oh no, don't do that, Monkey D. Luffy. I mean, B minus A by L is approximately 0. Don't neglect that. Then there is no point. Here the question is find it as a function of x. You have to find it as a function of x, so you cannot neglect it. I think we can use that fact that E is rho, which is resistivity, into J. Therefore, E will be equal to rho into this term. So it is rho I by this whole thing out here. So pi and A plus B minus A by L into X, and this thing square. So that's the second answer. Yes, that's the second answer, guys. Everybody, I hope you guys got this. Excellente, Yalini. Yep. Can you explain about degree of freedom of marker? My God, Sudharani, I will definitely help you out with that. Why don't you do one thing? Just ping me on my Instagram handle. Yep, just ping me on my Instagram handle. I'll help you out with that. Okay. Right now, I don't want to break the flow. Yes. Very good. Sir, B minus A is L because current always passes parallel to surfaces. Nidish, B is a geometrical radius, A is a geometrical radius of this side, L is the length of this. So B minus A is not L. The question says B minus A is much lesser than L. This is not equal to, this is less than L. So the difference is not much. That's all they have told. That's all. That angle is very small. It's slowly increasing. That's all. Okay. So that's the answer, guys, for current density. And you just multiply by rho, you get the field. Yes, that's it. Let's do this question. Now looks very crazy, but trust me, it's not. Okay, let's do this. Let's see if somebody can solve this question in 30 seconds. If you get it, you will get it in 30 seconds, else you will take more than 5 minutes to get this. No, Venkat, these type of questions are not asked in JEE Mains. These type of questions are asked in JEE Advanced. These are not mains questions. These are advanced type of questions. Okay. Aman, it looks all easy once you solve it. Yep. Earlier, people will think of integration. People will think, oh, what should we do? So, you know, advanced plays with your mind more than anything else. The questions are not very difficult or very lengthy. Very rarely you get those questions, obviously. But most of the times they play with your mind. In mains, it's very straightforward. Formula, done. Formula, done. 2 steps, yes, done. Okay, let's see how many of you guys get it. If anybody gives me the answer really quickly, I will be very impressed with you. I'll be very impressed with you. Come on, guys. Anybody can give me the answer really quick? Yes, it's complex. Ankit says done. Thank you, Dipanshu, so much. Yep. Come on, figure this out. What do you think? Answer is R by 2, says Shivani. I'm not sure. Let's see. My rank in advanced was 3900, Pratham. Sudhani says 4. And my physics marks were almost full when I wrote my JEE examination. Ojasvi says 0. 3R says Sai Telugu and it's a Tukka. Hariharan says R. Science, Sense of Science says R by 2. Rakesh says 3R. Somebody is saying R. Yes, Nitish, this is also for JEE 2021. Tell me, bacha, syllabus is same. Hai na? So if you are a 2021 student, why not? It's a free lecture. Please come and attend. Make the best use of, you know, the knowledge. Wherever it is there, just get it. Don't think about it. Where are you getting the knowledge from? It is for free. Please take it. Okay. Now I'll tell you what. Many of you did not see one very simple thing. Okay. Do you see this point, this point, this point, and this point? All are at the same potential because there is a wire. Do you see that? There is just a wire. There is no resistor here, here, and here. Did you just see that? Did you just see that? Did you just see that? Yes, there is a wire. There is potential which is same everywhere. Now, tell me one thing. If I have a wire, and I connect a resistor like this, tell me, should I worry about that resistor? Can I ignore that resistor? Can I replace this with just a wire? Help me with this. Is this correct? If I have a resistor in parallel with a wire, is this resistor going to be useful or useless? Can I remove it? Come on, think about it. Come on, think about it. Do you see that? Isn't it useless? Isn't it waste? This is useless as, I don't know, whatever you want to say. Yeah, it's useless as a swimming pool inside an ocean maybe. I don't know. Okay, so basically what I can do is get rid of all these nonsense out here. This is useless. It's nonsense. It's not needed. It's a waste. Current is going to go here. So just forget it. Just forget it. Now it looks simple. Now it looks simple. But wait a minute. There are few more useless resistors out there. Look at these two gentlemen out here. Look at these two people. Look at these two gentlemen. There is a wire between their two ends. Aren't these two also useless? A plain wire, guys. This potential, this potential, this potential, this potential is same. Why the hell will current flow through these two people? Gone. That means, forget it. It's just a wire. It's just a wire. That's it. This is the circuit. So what is the equivalent resistance? Come on, let me know in the chat box now. Come on, think about it. Yes. What is it? Hey, Malik Fazan. No, it's not 3R. Come on. What is the answer? What is the answer? Yes, Ashwin. It's 2R. Beautiful. And that's the answer, guys. That's the answer. That crazy circuit was nothing but this. Look at the way JEE Advanced is going to play with your mind. Look at the way they are going to fool you in the exam. They're going to trick you into thinking that, hey, this is a difficult problem. You need to use KVL, star delta method. You need to know something more. You need to know about Thevenin's theorem. You need to know about some complex circuit KVL problems. No, you just need to look at it properly. You should not be blind. That's all to make you understand this problem. I have just made use of these beautiful simulations. I hope things were very clear. Yep. Let's go to the next one. Let's go to the next one. Yep, Ashwint. Yes, that's betrayal. Look at this question. Question is again find the equivalent resistance between these 2 points. Let's see how many of you can get this. Oh yeah, symmetry. I know symmetry. Use it and let me know what the answer is. Waiting for all of your answers out there in the chat box. Very good. Yes, correct, Aman. That's what JEE Advanced checks. It does not check only your memory. It checks your basics. Right from basics, the fundamentals. Can you see things? Okay, some of you are saying 3R. Well, it's not so easy. You just need to work it a little bit. Think about it. Symmetry and Wheatstones. Okay, I don't know. Maybe, may not be. Symmetry for sure, yes. Okay, come on, my warriors. Some of you are saying 2R, some of you are saying 3R, some of you are saying 3R by 2. Ankit says remove all the wires. Ankit, if I remove everything, nothing will be left. Resistance will be 0 or infinity. Sudaran is confused. Okay, I'll tell you what, use this logic. No star delta method. Use my trick. What is my trick? Listen to me very carefully. Shreyas Sir's trick. I mean, it's there in many books also, but many people don't pay attention. If you have something, complex circuit, okay, some complex circuit, these are the 2 points about which you need to find resistance. Okay, there is some complex circuit, I don't know, something crazy, I don't know. You see that there is a line of symmetry, perpendicular to the 2 points about which you want to find the resistance. What is the trick? If there are 2 points about which you want to find the resistance and you find that there is a line of symmetry and which is perpendicular to it, then what happens is all the points on this black line of symmetry, all these points on the black line of symmetry are at the same potential. Now check if this trick works. You can clearly see over here, between these 2 points, I want to find the equivalent resistance, and clearly there is a line of symmetry over here. So you will be like, sir, okay, then this point and this point has the same potential. There is no use of that because this point and this point are inside the resistor. So what do? You make few points. Yes, you make the points. And how do you make the points? Here is the next trick. Trick number 2. If you see that there is a junction, over here and it lies on the line of symmetry. If you see there is a junction, there is a node, there is a point which is connected and it lies on the line of symmetry, split that junction. How? Like this. Make it go like that. Make it go like this. Yes. Now I have split the junction into 2 parts and connected it with a wire. That's it. And it's lying on the line of symmetry. That's all you need to do, because then this part will become useless. This part will become useless because they both will be at the same potential. Yes, both of them will be at the same potential. So that's why it's useless, because it is on the line of symmetry. Is that clear? Yes, separate that junction. So let's do this. So everything what I told, the tricks are working. There is a perpendicular bisector and that's the line of symmetry. Number 2, there is a junction. So expand the junction like this. Look at that, what I just did. Everybody observe this once again. There is a junction, expand it. Okay. Now do you see which points are at the same potential? This, this and this. 3 points. 1, 2, 3. So disconnect them because it's a useless wire which is connecting them. So just forget about it. Just forget about it. Now it's very simple. No star delta, nothing. You don't need that. It's a useless thing. If somebody is teaching that, they're just fooling you. Okay, remember that. This is 2R in series. So this together, how much will it be? 2R and R. 2R into R by 2R plus R, which is 2R by 3. So this is 2R by 3. This one over here is obviously again 2R by 3. Correcto? Next, this one over here, this is R and R in series. So it's going to be 2R. Yep, that's going to be 2R. Now the last thing, this and this, they are in series. So add them up and let's see what do we get. This one, this one, this one, this one, and this one. R plus 2R by 3 plus R. Come on guys, what is it going to be? R plus 2R by 3. I'll write it down for you. R plus 2R by 3 plus R. What is it going to be? Take the LCM. 3 is the LCM. 3 plus 3 is 6. 6 plus 2, 8. So it is going to be 8R by 3. Even this one will be obviously how much? 8R by 3. So now you have 3 branches in parallel. You have 3 branches in parallel. The top one 8R by 3, the middle one 2R, and the bottom one also 8R by 3. So guys, 1 by R equivalent will be 1 by 8R by 3. That means 8R, 3 goes on the top. Okay, they are all in parallel, plus 1 by 2R plus 1 by 8R by 3. That means 3 by 8R. I hope this is clear. Now 3 by 8R plus 3 by 8R will be twice of 3 by 8R, which is nothing but 3 by 4R plus 1 by 2R. So I can take LCM, just make this as 4R. So I need to get rid of 1 and put 2 over here. So 3 plus 2, that's 5, and divided by 4R. But that's, remember, 1 by R equivalent. So therefore R equivalent is 4R by 5. 4R by 5. Beautiful. Yes. Nidish, I also saw symmetry. That's why I was able to split that junction. So there is symmetry. Left is equal to right. So all the points on that symmetrical line were at the same potential. I also identified a junction and split it, and rest is simple series and parallel problem. Yeah. Yes. Capacitors chapter, Priya Suresh. Next lecture is going to be capacitors. Are you guys excited for capacitors starting next week? Yep, capacitors is starting. Yeah, nurture batch time, Prasanna, same time, 7:30. Guys, all my lectures are at 7:30. Please go behind. I have shared my schedule. Every day my lectures are at 7:30. Only the 2021 batch, which is the current batch which is passing out, those lectures are on Tuesdays and Thursdays, 9 o'clock. But otherwise, all my lectures, most of the times, are at 7:30. Yep. Parallel symmetry. Well, I'm not sure what you mean by that exactly, but Aman, this is the easiest way of doing it. Well, you can do it by other ways also, but it could be more complex. So that's the answer. By the way, let me tell you a little bit more about our batches which are about to start. Now, the reason why I want to talk to you about this is because it's very important. It's high time. If you have not yet enrolled into any coaching, or if you are not happy with our, with, let's say, a coaching which you have already joined, then understand, we are going to give you 2 teachers in our class. One is the main teacher, which is called as the master teacher, which is me or anybody like me. So this is something like me. And you are going to have a class teacher for a small group of students, and he is going to assist you with your doubts inside the class. Okay, doubts inside the class. After the class, if you have doubts, then there is a doubt. Okay, there is a doubt in-app facility, and you can ask doubts from morning till night. You can ask as many doubts as you want. And if you want a personal mentor for PTM, for scheduling, for timetable management, for strategies, you also get that in our regular course. Now, after every class, you are going to get notes in the form of PDF. You are also going to get every assignment after every class. You are going to get the Tattva module, both soft copy and hard copy. Now this Tattva module has all kinds of questions, simple, easy, hard, previous years mains, previous years advanced, every kind of question. And all our classes have quizzes, they are interactive, and they are a lot of fun because of the leaderboards and the competitive spirit that you get. Now, how do you see, how do you compare all the different packages? One is the light version. You get everything like the online classes, PDF, test series, notes, Tattva, doubt solving inside the class. But if you want somebody to help you outside the class for doubts, then you go for the classic version. And if you want a personal tutor, personal mentor, then you go for the plus version. Now look at the prices. Per month the price is 3,600 for light. For classic it's 4,950. Now I'll tell you what, these prices are as much as you would pay for a normal tuition for board examination. If you don't believe me, just go ahead and ask any good tutor out there in the market, how much do they charge per month for board tuition? Now this is not board tuition, this is JEE. You get KVBY, you get CBSE, you get everything else apart from JEE as well. There are micro courses, test series, everything. What more you want, and that too sitting at your home. These prices are throwaway prices when you use the discount coupon SHHPRO. And best part, you don't have to pay this full amount if you take 1 year. You can use EMI option, so effectively your price is this much. So you see the advantage. Yep. So I'm really hoping to see all of you in the pro subscription batches which are starting on 14th of June. If you have any kind of query, do let me know on my Instagram account, alright, which is Shreyas_Vedantu. Okay, you can ping me over there and I will definitely help you out. Yes, I'm going to definitely help you out there. Yeah. Well, the NEET exam, I don't know, nobody knew when is it going to be conducted, what will be the exact date, nobody knows that. Nobody knows that. Yep. Okay. Cool guys, thank you very much for joining in. And yes, see you guys again next week. And also tomorrow you can gate crash the 11th standard Menti quiz, and on Saturday a special session, and Monday onwards we are going to start with capacitors. Take care guys, and please stay safe, and yeah, please take care of yourself and start studying. We have already completed 3 chapters in the Pathfinder series now. We are really advancing at a good pace. Don't worry, we are going to complete the portion. Bye bye, have a good time. See you, hasta la vista.